Good afternoon, everyone. Welcome to the webinar, Unlocking the Benefits of AI-Driven Predictive Maintenance in Oil and Gas. This is the first part of two-part webinar series. In this part, we are talking about business case of adopting AI-driven maintenance. The second part will be about solving specific maintenance issues that you might want us to see how it can be solved using data science techniques. Today, I have with me Mr. Trevor Bloch, who is Group CEO and founder for VROC. VROC is a platform which enables AI-based predictive maintenance. I also have with me Mr. Razik Aznam, who is heading offshore operations for PETRONAS. A warm welcome to both Trevor and Razik. Nice to have you with us, Trevor and Razik.
Thank you.
This webinar will be 45 minutes long. First 30 minutes, we will describe the PETRONAS experience and VROC platform. Then we will handle questions from all of you for the last 15 minutes. You can see the chat window on the right-hand side of the screen. You can post your questions when in the Q&A session, and then we will answer those questions in the session. Please note that we will record this webinar, and all those who have registered, we will receive a link to the webinar, and you can review the webinar later as well. So let's dive right into why AI-driven predictive maintenance in oil and gas. As digital transformation is picking up pace, the impact on oil and gas and the benefit it offers is tremendous. The first use case, any oil and gas companies nowadays are looking at how it can optimize the spend on maintaining the assets. Any dollar reduced in maintaining the assets directly impacts the profitability of oil and gas companies. In today's market, this is really very important. And most of the oil companies that we are seeing have either started or seriously considering initiatives in AI-based predictive maintenance. Some of those, Wipro as a company has been participating in either enabling our customers adopting the right platforms or solving the specific maintenance issues that they have using various tools available with them. So let's look at how PETRONAS has gone through in implementing an AI-based predictive maintenance through VROC platform in its Turkmenistan operations. So Razik, thank you for joining us today. My first question is, when we talk about the long case study, how was the scenario in operations and maintenance before you implemented AI-based predictive maintenance?
Okay, Assalamualaikum and very good afternoon. Thank you, Syed, for the questions. Okay, basically, the scenario in operations and maintenance before we implemented going to the journey of AI. Basically, we have a distribution control system. It's a PLC base in our offshore and also onshore operations. And pre-2016, also 17, no such thing as predictive. And basically, we have a preventive maintenance program, either in the time base or a condition base. So some of the engineers would do an extra mile to be on board of offshore platforms to do all of the analysis in offshore, where they have to retrieve the data from the PLC historian and map it according to their own experience. Post 2016 or 17, like that, we have an initiative to pull all of the DCS of this PLC data for analysis and monitoring purposes, and we call it as PI server installations. So this is the starting point of trying to get predictive analytics. Yeah. Which these are from the PI servers, we have all the data, and from my experience before, what we did is basically we get all this historian of the data from PI servers, and we map it according to the high and also low settings. We develop these high and low settings so that it becomes our support and also resistance, basically. So when certain parameters breach that support or resistance, something's bad going to happen. Either the equipment's going to trips or some failure is going to happen. So that was the starting points. And I have the experience of getting one practical students, actually a trainee from one of the Malaysian university, who tried to get this idea of predictive, and he's using some sort of algorithms in his laptops, but unfortunately he can only do in his laptops, right? So he cannot do much until I get this opportunity of meeting one company called VROC, where it can basically predicts all of my time to failure of our equipments, basically.
Very good, very good. So when you started, formally going into the kind of project that you eventually went into, what were the critical goals and success factors that you put in place? How did you justify to invest in such kind of a technology?
Okay, I have a very a valid pain points during at that particular time. I was moved from one platforms or one field called Duyung Rasak and Tangga Barat to take care of one particular field called Dulang. And for Dulang at that particular time, we are having so much headaches with regards to one of our gas compressor. And this gas compressor is so critical, it contributes to a gas lift, which contribute to a high and also sustain oil productions. If we lost this compressor, our production gonna be cut or reduced by more than half, something like that. The pain that I'm having was the reliability of this compressor was very bad, very bad, and the efforts that being put into this getting the reliability up for this compressor was enormous. A lot of efforts we have been calling all the experts all around the globe, trying to resolve the issues. So I cannot rely on a technical expertise anymore. When I joined into Dulang, I wanted a paradigm shift to resolve this issue. And the highest number of, the highest uptime of this compressor to be running smoothly is only 2 weeks. Normally, it will go up to 3 to 4 days and it will trip. And then the highest achievement we could have is about 2 weeks. If we could have 2 weeks, then our team gonna be celebrating. We're gonna have a party. So up until that particular moment, that a paradigm shift need to be conducted, where I don't want an expert to tell me what's the problem with my compressor. I need the compressor to tell me. And how I'm going to do that is basically the data of the compressor tell me, or the data of the whole platform tell me what's the problem with the compressor. So during at that particular time, we get this proof of concept from VROC, and at the same time also I come up with a team with 4 brilliant young minds, young engineers that spent about almost 1 month just to find out what is the problem with this compressor, right? So a time span of 1 month of these engineers not doing anything else, compared to only 10 minutes artificial intelligence with big data analytics coming from VROC, that is a huge difference, which the output from these 4 engineers within 1 month compared to a system can give me an output of only 10 minutes. So that was my turning point, actually. And a lot of negative thinking, or those people who didn't believe in AI during that particular time, and we are talking about 2017, yeah. Mm-hmm. So artificial intelligence was very new. It was a rocket science on that particular time. It was not like now. So the acceptance of the people is quite bad on that time. But we keep on belief on this particular application, thus we willing to spend a few millions just to get this application into our platform, and the cost savings or the cost elimination, like cost reductions or cost avoidance that we implemented by the application was very huge. Was very huge, and the news goes up until our vice president actually.
Wonderful, wonderful. So, Razik, can you share how did you how did you went about going to execute this project? The details of project execution, various phases. How did you plan it? How any tidbits of how the maintenance organization went about it? What was the involvement from different parties within your organization as well as from the VROC team?
Okay, we started off with, of course, the most basic thing is which is the data cleaning, data cleansing of all of the data coming in from offshore, coming into our PI servers, which that is the most basic because rubbish in is rubbish out. So we spend quite lengthy on getting the data clean. Once that is ready, we try upon a few modelings, and then we continue with a training for our staff. It was very good up until last year, I believe, or 2018. 2018 is the dates that I moved up from Dulang. So in 2018, we managed to train, or VROC managed to train about almost 100 packs of young engineers on artificial intelligence. And those acceptance was very good. And the modelings that being done by those engineers trying to get their things done was excellent. So from after the trainings, then we can see that the like I said, the acceptance of the engineers was quite good. They keep on building their models, and with the helps of VROCs, the model was improved, and the prediction is also improved. Where you get all the data reliability from offshore, and your prediction is improved, thus you have a lot of helps in getting your time to failure of your equipments. And in 2019 was the time or the year, the first year, the Dulang platform having meet with their KPI on productions. Although I live in 2018, but I believe because of the artificial intelligence from VROC, that one of the factor to get this thing done. But on top of all, this is not a plug and play things. We require such dedicated engineers. It's just a tools, yeah. Like I mentioned to all of my engineers, this is just like a hammer. You still require those people with hands to do all the jobs. It only simplify things and portray whatever that you wanted to see on the right time, actually.
Right. So Razik, so you have, previous to implementing VROC platform, you had preventive maintenance paradigm in your organization. Then you put in the predictive maintenance paradigm in your organization. So how do you measure now the benefits after the project implementation?
Okay, the measurements, I would say that the reliability of our equipments, like for example, the first example that I give is where the pain that I'm having, which is regarding the compressor, that one of the compressor that we try to improve on. After the implementation of AIs, like I mentioned before, the highest or the longest uptime of this compressor is only 2 weeks. We managed to prolong the uptime of this compressor or increase the reliability of this compressor from 2 weeks to 3 months without any trips.
Wow, that's a significant
So that
improvement.
is a huge achievement actually for the team.
Right, right. Thanks, Razik. So thanks for sharing your experience. So we will move to the next. Before we move to the next segment, we will just run a short poll for the audience, and it should come to your screen now. So we are trying to find out, in your case, what is the main challenge for initiating an AI-based predictive maintenance program. We will keep this for about a minute or two to see the inputs that you might have. So sometimes people do not initiate such projects because there is a lack of data scientists in the organization, or they do not see business value, or there is perceived high investment. Or maybe in some cases there are lack of sensors or data unavailability. So which one of these is in your case do you see? I hope this is an important aspect, because anyone going in for such kind of an implementation will like to know what kind of challenges we need to overcome, and we will try and address these challenges in our next segment. So I've seen these inputs. I've end poll. So we see that there is the largest one, 70%, is perceived high investment amongst all the participants. The second one is lack of sensors or data available, which is 20%, and then do not see business value, 10%, but not the lack of data scientists, right? Thanks everyone for participating in the poll. Now let's move on to the second segment, which is talking about VROC's predictive analytics solutions. So Trevor, in a typical AI predictive maintenance program, what are the typical challenges your customers are trying to overcome, and how does your technology help overcome these challenges?
Yeah, hello everyone. Thanks, Syed, for the question. I think for our clients, I think 2020 has been an especially challenging time, and the problems that they're experiencing this year are quite different from the problems that they've experienced in the past. The main challenge that we're actually seeing is just the reduction in the amount of people or personnel that people have offshore or even in remote areas to maintain their assets. So, and this is obviously due to COVID and the lack of, people can't share cabins offshore anymore. So then, a lot of our clients are seeing that they only have, half, or even some have a third of the amount of people offshore that they used to have. And so obviously that makes doing anything, doing all the stuff that you usually do a lot more difficult. I guess coupled to that, the fact that a lot of people are working from home and they're not working from the office anymore, making collaboration a little bit more difficult. And I guess also the increased fluctuations in commodity prices is also having a significant effect. So a lot of our clients are now saying, we've got half or a third of our people offshore or on our facility that we used to have. How do we do all the things that we, were doing last year with only half the amount of people? And I guess, they are looking for technology solutions. And this is where technologies such as predictive maintenance can provide a significant, improvement to their situation and help them through this time. Because I guess, if you've got a team of people offshore, or you've got a reduced team of people offshore, it's essential that they're doing all the critical things that need to be done. And so with predictive maintenance, if you've got AI looking over all the data of your facility, you've got a hit list of the critical items that you need to tackle now to keep your facility running. And so those are the items that you can have your offshore team focus on first. What are the critical things we need to do to keep this facility running and to keep it safe? We can get that from, the AI and the predictive maintenance. It can identify what those critical things are. And once those things are taken care of and we know our facility is reliable, we can then move to the preventative maintenance items, which may be, although still important, they may be less critical. And so, when clients have, lots of data, they've got big, complicated assets, there's a lack of data scientists at the moment. There's a limited number of large levers that you can pull to improve your situation. But, when you're seeing as Razik mentioned, significant improvements in operational efficiency using predictive maintenance, this is one of the, the major levers that you can pull to improve your situation. So I think that's what the major challenges we're seeing is, how do we do all the things that we were doing previously in this much more competitive, much leaner environment that we're facing at the moment.
Right. Thanks. So, Trevor, how easily, your technology, VROC Predict platform, be typically implemented in an operating plan?
Sure. So I guess the whole idea behind VROC is to try and have a more or less off-the-shelf solution that's very low cost to deploy. So the idea is to eliminate that large upfront consulting effort that's required to implement these sort of systems. So, obviously when we implemented the solution with Razik, that was in 2017, and we've changed a lot since then. So a lot of the stuff that we had to do during that deployment are now automated. So, in most cases, there's no need for new sensors or new equipment. There's no need to clean up your data now. As I said, there's no big upfront consulting or implementation cost. Basically all we need to do is to establish a connection to your data sources. And VROC has obviously standard connectors to, Honeywell, Emerson, GE, ABB, Siemens, all the standard controls and DCS systems, PI historians and the ABB historians, to your IBM Maximo CMMS systems or SAP. We've got standard connectors to all of those. So the idea is that you can deploy the solution very quickly with automated connectors and no upfront cost. Once the solution's deployed, it automatically then streams the data from your historians into the VROC system, and then you can start building models basically from it. So the idea is that from the time that we're engaged, I guess, or if in the case of VROC, in the time that VROC's engaged to the time that you're actually building models and finding value in the solution, it can be as little as 3 or 4 weeks. The largest time period is usually getting access to the data. So going through your secure connections and going through your IT security policies. But once that's finished, it's only a number of weeks before the solution's up and running. So I guess what you can do is with these sort of solutions is it's not a big change. You don't sort of have to drop everything that you were doing previously and move to the solution. It's supplementing what you're already doing. So it can run in parallel with what you're doing until you gain confidence and understand how this new technology works, and then you can gradually implement that or sort of integrate that into your standard operating procedures, which is the way we do it. So although there's a perception that there's a large upfront cost, in reality, this technology now is quite commoditized, and it can be quite effective and low cost to implement and roll out.
Great. So, you have done a number of projects globally across oil and gas, upstream, midstream, etc., as well as downstream. So, what sort of challenging prediction projects in maintenance area has your team attempted? If you could give some, that would be really wonderful.
Yeah, sure. So the interesting thing is that because the platform is end user self-service, so it's designed to be driven by the engineers and subject matter experts, the majority of the problems that are solved on the platform, we don't actually know what they are because the end users are actually going on there and building models themselves. So the idea is that engineers and subject matter experts can build models without any data science experience. All they have to know is the problem that they're trying to solve, and they can do that on this sort of platform. So the vast majority of problems, the thousands and thousands of problems that people are solving, we don't get to see them because they just do it themselves. I guess some of the ones that we have tackled recently, I guess one that stands out is an upstream sand problem that we had with one of our FPSOs. So obviously sand on an FPSO is a big problem. Sand is very abrasive. It causes wear in pipes, valves, pumps. It fills vessels. It's sometimes quite difficult to get rid of. You have to flush it through your system. And we had a FPSO that was having significant sand issues. So, and these sand issues, the sand was coming in bursts, and they weren't sure what was causing it. When is this going to happen? When am I going to get the next sand burst? And so what we were able to do is look at their data. The other thing of interest is that they didn't actually have any sand monitors on any of their risers or any of their wells. So what we did was we took all the data from the subsurface, we took all the well data, we took all the data from the top side, and just using that data, we were able to, using AI, build a model of, when we think sand is going to happen, when do we think the next sand burst is going to happen. And so this model ended up being surprisingly extremely accurate. And so what they were able to do is predict sandbursts before they happen and identify the risk factors that were driving these sandbursts. And so, although they haven't completely eliminated them at this stage, they've been able to reduce them and understand them better. And at the moment, just being able to stay out of those dangerous operating modes that might cause a sandburst, they're predicting to save about, $11.7 million this year. So, that's a really, really complicated problem involving lots of different variables, both subsurface and topside, that we can solve using this sort of technology. I'll give you another quick one, which is a glycol issue, which applies to various facilities. Obviously, glycol is used to dehydrate gas, and again, having the right moisture content is important, because if you're selling the gas, it needs to be a certain moisture content. It can also cause problems throughout your facility, such as increased corrosion, hydrates, all that sort of stuff. So having a properly functioning glycol system, or effective functioning glycol system, is extremely important. And so again, one of our clients, we were monitoring the glycol system for them, and what happened was our system started predicting high moisture content. So it started predicting that the glycol system wasn't effectively removing the moisture from the gas. And in this case, what would normally happen is once you reached a certain point, it would cause a shutdown. Once the moisture content got too high, the system would automatically shut down, and that would be a total plant shutdown. But what they were able to do, because the AI not only predicts the undesirable events, so it predicts that there's going to be a high moisture content, but it can identify what the root causes are. So you can understand what's driving that high moisture content. The operations personnel were able to take the appropriate action, because they could understand from the AI results, what was causing the high moisture content. So they were able to take the appropriate action before the glycol system, exceeded its limits and before a total plant shutdown occurred. So in this particular case, although they weren't able to solve the root cause of the problem, they were able to take a very rapid, immediate action to mitigate the problem, and they're giving us more time. So this is about another, $1 or $2 million saving by doing this. But without using AI, what would have ended up happening was this plant would have shut down. But now that they've got this information at their fingertips, they can make really rapid decisions as to what to do next to prevent these undesirable things from happening.
Interesting. So now my next question is to both of you. What are your suggestions for our audience regarding initiating an AI-based predictive maintenance program?
I'm happy to go first quickly. I guess from our perspective, I guess what we've seen is that, the idea with these things is they're no longer a huge project that needs to be done up front. You can start off very small with a POC, and you can evaluate the results. So the idea is do a very small POC. They're a very short time to implement. You don't need any more hardware. You just use the existing stuff that you have. And you can prove that the technology works for you. You can prove it yourself that your team likes it and it's suitable. And once that happens, it's very easy to scale this throughout your organization yourself. As I said, with our particular solution, the end users and the engineers can build models themselves. So you don't need to hire consultants like us to build the models for you. If your engineer has a problem, they can go onto the platform and build the model themselves without any data science experience. And so when you've got all these different subject matter experts building models themselves, this product naturally scales throughout your organization. What we've then seen is that once you've got your predictive maintenance under control, so usually we see sort of 6 to 9 months it takes for an organization to get their predictive maintenance under control on the platform. Once that's under control, you can then look at other things such as, process optimization, which you can use the same sort of products for, to now that you've got a highly reliable facility, how do we optimize the processing to optimize exactly what it's doing to get even more value out of this technology? So I guess that's my suggestion. Start small with a POC and then scale rapidly to gain the value.
Right. And Razik, from your experience, what are the suggestions from your side?
Beside of, I don't want to talk about technicality of it, because the biggest hurdles that I'm having during at that particular time was the belief in AI, actually. Like Trevor mentioned, it's not a plug and play thing. You require SME, subject matter experts, and you require engineers to interpret the data that is coming. But the most important thing of all, if you don't believe AI could help you, then you're gonna feel big. That is the most important thing, the belief of AI could help. Well, my suggestion, or if you want to ask me, if you ask me what's the best solutions for that, is actually finding somebody or finding a team that really believe that this thing could work. When I started off getting VROCs into PETRONAS, I appointed a few engineers to make it happen, but it didn't because of that belief. But when I switched over after 2 months or 3 months after that with one engineer who really believes in those data, big data analytics, and he really works hard on it to make it happen. And when he get it in line, it works tremendously. So that is my suggestions. If anybody wanted to go for this, get somebody who you think could deliver this and have the belief that AI could help you.
Right. Thank you, Razik. That is, I think, the most important aspect of the implementation. So let us now move to the final segment of our webinar today, the Q&A session. I urge all participants to write their questions which we should handle in this session. There are a few which are already there, so I will start taking them one by one. So first question is, I think it is regarding the case study that you talked about, Razik, and it is about compressor uptime. The question is, what was done differently? How was uptime increased? I think the question is somehow you have answered this question, Razik. The question is about how did you increase compressor uptime in terms of using the models, etc.
Okay. So, like I mentioned before, there were about 5 to 6 years the initiative or the efforts getting the reliability of this compressor, and the most difference, the difference between the efforts that being done before and what have the AI help us is basically the problems when they're having like 5 to 6 years are looking into at the compressor itself. But the major problem is not at the compressor itself. The major problem is the intakes towards that compressor. So how does AI works is basically it shows you the things that you wanted to see. So if you are looking at the compressor itself, you won't find the solutions. The solutions that being predicted, or the solutions or the parameters that being shown in AI, none of it referring to the compressor, meaning that all of the sensors in the compressor is good. The problem is the intake with the compressor, the surging of the gas intakes. So we have like the problem with my compressor at that particular time was the gas intake was intermittent due to a liquid sludge. So there will be a gas, a continuous gas, then at the same time a liquid will hold up at the pipeline. Then once the liquid or the pressure is enough to push all the liquids, thus you won't have any gas because it's all liquids. Thus it keeps the compressor surging. Thus it will trip the compressor. So if we are keep on looking at the compressor itself, you won't resolve this thing. So the only the solutions is basically to calibrate or to resolve the issues with regard to that slugging flow. So once we've done that, the compressor can run for 3 months without any trips.
Right. Thanks. I hope that that question is answered. I'll move on to another interesting question, and I'll word it slightly different. So the question is to you, Razik, is why did you choose VROC rather than other companies, and what made you choose VROC Predict as a platform? I hope you were able to hear me, Razik. Shall I repeat?
Sorry, again, sir?
Yeah, the question is, why did you choose VROC platform? What made you choose VROC platform against others?
If you ask me, my answer would be I'm desperate at that particular time.
Okay.
I require at least one application that those people who can't speak about machines or the workers or the staff of that particular company cannot speak about compressor at all. None of them knows about hydrocarbons. None of them talk about methane, ethanes, and so on and so forth. So I just require those platforms just to give me data that will be interpreted by engineers, my engineers. So I have not seen any, I haven't seen any company done that before. Most of those companies that comes into oil and gas, they are expert in one area of expertise, of course. But VROC came in with zero knowledge about oil and gas. The only experience they have with, I believe at that particular time was a cargo handling company, I'm not sure at that time. So that is one of the problems that I had to convince people that this company that I'm going to hire or going to have a contract with a zero background of oil and gas and zero experience on oil and gas. But they were the first who come to me. Or no. I come to them actually.
Okay. Thanks. I hope that question is answered. So there's another question, and for this I require Trevor's attention. The question is, can you share a sample roadmap with steps and estimated timeline along the way to realize a proof of concept?
Yeah, sure. I mean, we can send out a formal roadmap if that's what the question's asking. But I guess, as I said before, a POC is relatively straightforward, and it's kind of what we try and do. We try and make it, easy to get a POC off the ground. I guess, as Razik was alluding to as well, is that we won't do a POC for a specific piece of equipment. So there's no point giving us data from just your compressor, because often the problem that you're experiencing isn't directly related to the compressor. It's from somewhere upstream or downstream of the compressor. So really, for a POC, what we try and do is we try and get the data from all the facility for a period of time. And once we have the data for from the whole facility, we can then look at what your most difficult or most high value problem is, and then use that as the subject of the POC. So POCs generally, as I said, take a couple of weeks. So, we normally take a week or two to gather your data once we get access to do it. And then the POC might take another couple of weeks. So really, you're looking at a 4-week timeline for a POC. And then if you want to scale up after that, obviously you can just continue on after that and scale the solution as you see fit. What we found to be quite valuable as far as POCs go is to do a 4 to 6 month trial of the system, so to have it actually running with real-time data in production to show you the sort of benefits that can be realized. And that tends to work very well, rather than doing a single problem that you want to solve. Just have the system running in real time with real data, so your engineers can use it and understand how it all works and get their head around what the technology actually does. So usually those are 2 ways we do it. We can do the offline POC on a single problem, which is good, but we find the more effective way, and clients get more value out of having a real-time, 4 to 6 month trial of the solution.
Right. So I have 5 minutes remaining to the webinar, and I urge all participants to ask any questions that we should answer. There is one that I will ask Trevor, is about where can the technology be applied, either new or legacy? And is it necessary to install in sensors?
So, I mean, the technology can be applied across any type of facility. You know, we've got some facilities that are quite old, built in the 1970s, that are running on our platform, and we have some facilities that are brand new, that are just out of commissioning, that are also getting really good results. Obviously, the older facilities, you know, they're the focus for them is to maintain reliability of the aging asset and to try and, you know, get the most production out of it as they can. For the newer facilities, the focus is more about understanding how this complicated facility works, because obviously the newer facilities have sensors everywhere and sensors on sensors, and very complicated, you know, recirculation and heat exchange loops. How do we understand how all this works and what's actually driving some of the undesirable effects that we're having? So really, you know, this technology can be applied to any stage plant. As for the sensors, what we find is that in the vast majority of cases, we don't need to install new sensors. So the sensors that you already have on your facility are sufficient to do this sort of analytics. The only time we have had to install new sensors is on, on some drill rigs. Some drill rigs are very rudimentary, and so we have an IoT package that you can go out and install, you know, wireless sensors on the critical piece of equipment to monitor those. But for the vast majority of cases, the sensors that you already have on your facility are sufficient to run the software.
Right, great. One final question before we end the webinar is it possible to host the system on site?
So for VROC, yes, we have sort of 4 deployment methods. So you can either stream data to a VROC data center, to the VROC cloud. If you have your own public cloud, AWS or Azure, you can install the system on your own public cloud. We also have an on-prem option. So if you've got your own data center, your own servers, we can install the software there. Or you can have a VROC Cube solution, which is an off-the-shelf server where you can just roll it into your data center, plug in your power and Ethernet, and you've got a predictive maintenance system running in your own premises. So there are a number of deployment methods depending on what your preference is.
So there's one more question that's just come in. So the question is for you, Trevor, does the system automatically change maintenance timings in the CMMS, or is this manual based on system recommendations?
The great thing is this is automated. So rather than having, I guess, regular time maintenance, I mean, for some things you're still going to have timed preventative maintenance. But the idea with this sort of predictive maintenance solution is that if you do identify something that needs attention, we can automatically raise a work order in your CMMS. So generally, you know, if we find that a motor needs to be tested or there's some piece of equipment that needs to be serviced, the AI can connect to your CMMS, and we've done this or SAP system or whatever the case might be, and it can raise work orders for you to perform the inspection or to perform the work. Obviously, to get really specific work orders, you might need quite a reasonable amount of data. So that might not apply to a facility built in 1970s, but for the newer facilities, we can provide really specific advice as to what work needs to be done on it at any point in time. So prior to equipment failing, we can raise a work order and say you need to fix this by this date to ensure that your plant is reliable. So yeah, definitely automatic integration with CMMS is something that we do as a standard.
Thank you. That brings the end to the Q&A session. So thank you, Trevor and Razik, for joining us for this very informative webinar. I hope this is useful for all our participants. But we have the second webinar, part 2, associated with this coming up. Please, I urge all the participants to register for part 2. We will send out a link tomorrow with the recording of this webinar. And in part 2, we will basically look at specific maintenance issues, and we will deep dive on these topics on how this can potentially be implemented in VROC Predict. So please do send your use cases on the email ID solutions@vroc.ai. This will be in the chat window as well, and we will attempt these in the second part of the webinar. So thank you, everyone. for joining the webinar. Thanks for your time.